Okay, now we're going to talk about regenerative gas turbines. And essentially, what the regenerative gas turbine does is it takes the hot air that's coming out of the turbine that would typically just be dumped into the atmosphere. And since it's hot, why don't we use that to basically preheat what goes into the combustor, thereby lowering the amount of heat that I need to put into it. So that's what I have here, right? So the air comes in from, the atmosphere, atmospheric conditions, gets compressed, then goes through that regenerator, that preheater, then into the combustor. Okay, so now Qin is going to be smaller than it was because it's been preheated, into the turbine, out of the turbine. And again, this is where it would typically just get dumped back into the atmosphere at a high temperature, but we're wasting that temperature. We're wasting that heat. So that's where we pull it back around and use it to preheat that, right? Because again, temperature at state 4 is much higher than, say, the temperature at state 1 or even state 2 after the compression. So again, use that heat to bring up that temperature, so I only have to go from X to 3 rather than 2 to 3. So again, because of this, the thermal efficiency is going to increase because my work isn't changed at all. The compressor and the turbine are doing the exact same thing they were doing. The only thing that's done is the heat is being reduced. The Qin is reduced, okay? So the thermal efficiency is going to go up if the heat in is reduced. So my Qin is actually H3 minus HX rather than H3 minus H2 as it would have been without the regenerator. So again, it's going to improve our performance with this in here. Now, there's something called regenerator effectiveness. Now, in an ideal regenerator, the maximum theoretical value of Tx is T4. And what I'm saying here is what's coming I can only heat up what's going into the combustor as high as what's coming out of the turbine, right? So if I'm dumping out of the turbine at, 300 degrees Celsius, right? There's no way for me to heat up any past that 300. So the best case is when T4 and Tx are the same, okay? So because of that, the regenerator efficiency is basically the ratio of what the regenerator actually gets as far as a change in enthalpy over what the ideal change in enthalpy would be. Again, this idea that the best case would be where Hx equals H4. Okay, so that's basically a measure of the regenerator, and these are usually 75%, something like that. Okay. Because again, you do definitely need some sort of temperature change in order to get a heat transfer, okay? But that's a measure of the regenerator effectiveness, and this whole idea of regeneration just, again, uses the heat that I've got to make it so the combustor doesn't have to work quite as hard.